I think it's time to start. So this was section 1C. Okay, so quick recap. 1A, we went over logical fallacies. So I think what they were trying to get at with like 1A is like, here's all the wrong ways to draw a conclusion from premises, is basically like what 1A is with the fallacies. 1B is when we start talking about propositions. So propositions are things that are going to be what? Either true or false. And then once we start talking about propositions, we can talk about ways to put those propositions together. And so we had statements like ands and ors and if-thens. And I think the ors could be like inclusive or exclusive. So I guess that gives you a little bit more truth tables to write out or something. But we basically had those three connectors: the and, the or, and the if-then. And usually if we use or in this class, it's going to be like the inclusive or. So that was section B. Section C, we started talking about Venn diagrams. So that was hopefully the lecture you watched. Is there anything I want to say on that? We started talking about sets. There's I can't remember what problem, if it was 4 or 6 or something. It was one of those, I think. There's some stuff with Venn diagrams. I don't know. Their questions were kind of weird, if I'm being honest. I feel like they weren't maybe the most straightforward questions. They were definitely something that made you think for a minute, but I don't know what to say. You might have to think. And I am recording. We'll start this. Ooh, I didn't join. So if you just came in and you hadn't joined, join it. Now I want to go to join my quiz. This is section 1C. All right, come on in. Sign on up. 664720. All right, slide 1, question 1. Let me fix this up so I ain't got no timer on here no more. All right. Decide whether each of the following statements makes sense, or is clearly true, or does not make sense, is clearly false. Explain your reasoning. The people who live in Chicago form a subset of those who rent apartments in Chicago. So a subset. Anybody want to give an input on how to think about subsets? So what is a subset? Do we understand? Let's see. Ooh, this ain't good. All right, so what's a subset? Someone tell me.
Category, I guess, smaller than the original.
Yeah, it's like it should be a smaller set than the original, right? All right, and so what was this question? The people that live in Chicago are a subset of people that rent apartments in Chicago. So why does that, why is it not, why does it make sense? Why does it not make sense?
Wouldn't it be because the people who live in apartment are smaller than like the whole population of Chicago?
Exactly. They should flip those words around. So maybe it was a little bit confusing because they had the sets flipped around. But the people who rent apartments in Chicago are the subset of the people that live in Chicago. So the bigger set is the set of people that live in Chicago. The subset is the smaller set would be the apartment renters. Is that making some sense now, hopefully? I know it's like 8 in the morning, and that's that's probably not the first thing you want to read on a homework assignment, but y'all were quick to hit the button there too, so I don't know. It's hard to talk about something if you're that quick. All right, any questions about this one? About why that one was false? All right, so what do we got next? I counted an irrational number of students in my statistics class. So what's an irrational number? There's probably one thing people are going to tell me if I ask them for an example. I think it's coming up too in one of the future questions. Can someone give me an example of an irrational number?
Pi.
Exactly. Yep. So it's a number that doesn't terminate, doesn't have a pattern, doesn't repeat, right? It's just a decimal. If you're counting some kind of weird fractional decimal of a student, oh man, are we awake this morning? I don't know how you're counting that fraction of a student, right? And I think that's their point here. If we're counting something, what sort of numbers are we using? We had those, I know in the notes we drew that number set. We had all those different sets of numbers.
Using whole numbers? If we're
Yeah. I would go with natural numbers. It's a little bit smaller set, right? The natural numbers are just like 1, 2, 3, or they also call them the counting numbers sometimes. The whole numbers start including 0, I think. And then integers, we start introducing the negatives. Don't call me, people. Okay. What does it say? Classifying numbers. So now we're looking at a number trying to classify which set it is in. Is that what we're doing? And we're looking at 13.888. And I think the sets go up. So like natural numbers is where we start with 1, 2, 3. Whole numbers is where we start introducing 0. Integers is where we start introducing our negative numbers. Rational numbers are numbers that we start introducing numbers that look like ratios. And so like a consequence of things being written as a ratio, like 1/3, it's going to be 0.3 repeating, right? If we look at 1/3, 0.33. So rational numbers, they either terminate or they have a pattern. That's the easiest way to talk about it. And usually that's the way like they try to define it. But to be honest, like the terminating or having a pattern is a consequence of them being able to be written as a ratio, I think is probably the more proper way to look at it. What did I do? Did I not mark the right one? Oh, shoot. I looked at it wrong. Okay, so that was number 13. That was problem 13. And the number was 888. Oh, whew. That looked like a decimal to me, so I totally got it wrong. It should have been a natural number. So 888 is a natural number. So you're going to put it, the goal is to kind of put it in the smallest set that we can, right? I know it's a whole number. I know it's an integer. I know it is a rational number. I know it's a real number. but the smallest one I can put it in is over here. So 888, it would be a natural number. And so if we were writing this thing in an Venn diagram, this would be the inside circle over here. We would keep getting to bigger and bigger circles. These are bigger and bigger sets. Okay. So I made the thing, and even I got one wrong. Helps if you read it correctly. Okay. This one is 3/4. This is problem 15. The number given is 3/4. Whew. Woo! Okay, so that seems like we're doing better here. That is definitely a rational number. We see 3/4. That is a ratio, and one number over a number. That would be a rational number. Okay. Any questions about this guy? Are we understanding the sets maybe a little bit more? I feel like I'm still waking up, personally. One more sip of coffee. All right, so what's the next one? I think it's another categorize this number. Oh, this is pi. Let's see. This one's a little tricky because it doesn't really say what pi is. So pi is a what? I think we said it earlier, right? Irrational. And so, whoo, yeah. It is not an integer. Integers are things that look like whole numbers, right? But like they also have negative numbers. Right. So it's definitely not an integer. Integers are things that look like -1, -2, -3, 0, 1, 2, 3. Rational numbers. Why is pi not rational?
Because it keeps going and it doesn't stop.
Keeps going, it doesn't stop. There's no pattern. There's no way to repeat it. There's no way to put it as a number over a number because of that. So if it's not here, where's it got to go? It is still a real number, right? There's no imaginary components in pi. It is still a real number. There's no I there, but it is not rational. So we have to go outside the rational in the real. I feel like maybe if I just do a Venn diagram of what the number sets, it's probably just like this thing, right? Start with the naturals. Sometimes, and this is another thing, right? This book, apparently they throw 0 in their naturals. Our book makes the distinction between the naturals and whole numbers. This would be the whole number set in our book. This might be another one, right? This is all the real numbers. This is natural numbers, whole numbers, integers, rational. This is the sort of like picture I'm hoping you have in your mind. Does this one have natural numbers and whole numbers? Yeah. So natural numbers, we have things like 1, 2, 3. When we get to whole numbers, we introduce the 0. When we get to integers, we start introducing things that look like negative numbers. And then rational numbers are things that look like 2/3. They're things that have either a terminating decimal or a repeating sort of pattern. Irrational numbers. So pi is a good irrational number. Other things that are irrational are things that look like square roots of prime numbers, so that we can't factor anything out of this prime. So like square root of 3, square root of 2, square root of 5, square root of 7. Those are all irrational. The other thing is Euler's number, which we will talk about way in the future, but we will talk about it. It's the little lowercase e thing. It's kind of like the opposite operation of your natural log. So it's going the other way. It's an exponential sort of function is what they use it for. Okay. Did I show you all this? I think I showed you all the script letters in the notes, but I could be wrong. Let's see. Oh, hush. All right, so what's the next problem? Use set notation braces to write the members of the following sets. The dates in July. All right, so there is something you have to write set notation. So you have to find the right symbols for that. It says you can use an ellipses. So usually you put a number, comma, space is a sort of formatting, right? You do a space after your comma usually. And this is a short answer, so I think it should.
Wait, I have a question.
Yeah.
Do we just put like the number, like the number, and that's it, or
The number for the dates in July. So how many days are in July? There shouldn't be 31. Do y'all know the knuckle trick? Do y'all know this one? Do y'all know that trick? Can y'all see this picture? I guess you okay now. If you count your knuckles, all the ones on the hump of a knuckle or have 31 days, all the ones in below have 30, except for February is the guy that's a little off. But July and August are the two that like are 31 days and they're back to back. Yeah, I had like for the life of me, like I could not remember this for the longest time, and this is how I learned it. It's still how I do it sometimes if I'm not too sure. Did I submit this? Oh, I didn't. Okay. So July has 31 days. They say you can put in ellipses. You should put like 2 to 3 numbers before and after your ellipses. In order to show a pattern, you should probably usually use 3 numbers. But here 2 numbers would probably be okay. And so there's a few things I'm going to pick on. We got one more person to hit submit. I'll give you a few seconds. There we go. Okay, does it say? It does not say on here. All right, so we want to do the days of July. Oh, I went to the next. Hold on. Pause this. I want to talk about the days of July and what I was looking for on there. So there is two things. Let me just pull up a Word document. Can y'all see this on the share screen, the Word document?
No, we just see the question.
But when I go to different things on here, you can see it, right? If I
Yeah.
if I search for Venn diagram, y'all were seeing the Venn diagram, right?
Yes.
All right, so y'all see the, okay. Let me think about the best way. I think if I just do a, no, I'll just do this. Now y'all can see it, right? The Word document, is it visible now, hopefully? Is it coming up on the share screen?
Yeah, we can see it.
Okay, good. All right, so the thing that I want when I do a set, the first thing that you need are these set braces. And then we want to do 31. So we're starting off with the first, what, 3 days? And it might have been, a lot of y'all might have got like stuff incorrect, sort of like a formatting thing, right? So it should have something like 1, 2, 3. That sets my pattern. And then I'm going what, 28, 29, 30, 31, something like that. Yeah. So my solution should look something like this. Maybe I could do it a little smaller so it puts it all on one line. But it should have looked something like this. If you really wanted to be wild, right, you could put in like, you can put in all the days if you really wanted to be wild. That's what we really mean with ellipses, and we're putting in every single number in between. I don't want to do that, so I'm just going to throw in ellipses. Questions about this? Are the people that like getting it wrong? Are you understanding like why you got it wrong? Oh, stop sharing that. Let's share quizzes again. Was it a formatting issue? Were you not understanding the question? That's kind of what I want to know.
Format.
Format. I put 7/1.
7/1. They wanted just the dates. Yeah, I guess I see. Yeah, that's fair. I think they were just wanting the days in July. But I see you're actually putting like 7/1 the day, July 1st. Yeah. What is this? Set of states. The perfect squares between 10 and 40. So what are perfect squares? Ooh, hopefully I can remember all of them. So what are my perfect squares? What's the first perfect square? Between 10 and 40. What's my first perfect square? Six. Yeah, I was talking about like what's the lowest perfect square. I guess it'd be 4, right? 2 times 2 would give you 4. I was trying to start off from the bottom and work our way up. but you're already starting with the set. So, the lowest perfect square, perfect square means the same number being squared, right? So if we start off with 2 squared, that's going to give me 4. If I start off with 3 squared, it's going to give me 9. 4 squared will give me 16. What 5 squared is going to give me 25. And then I got one that is what? I don't want to give y'all any more numbers. Okay, yeah. Oh, whew. Shoo-ba-doo-ba-doo-ba-doo-ba-doo. Oh. All right, so there's 2 people. Hit a button. Actually, you need to hit a few buttons for this one. Got to write a set. One more. Man, I had the hardest time remembering braces from brackets from parentheses. I don't know why. I think I finally got them down. I'll probably mess it up at some point in the semester, though. All right, so there's one person. Braces and do we know this? These are the braces. These are the brackets. These are the parentheses. So for sets, we use those set braces. Braces kind of look like braces that you put in your mouth. That's kind of how I remember it. All right, so there's one person. I'm about to hit end.
That might be me, sir. The internet went off of my phone, so I joined on my laptop.
Oh, you said that my EPU? Is that what you're saying?
Yeah.
All right. All right. What number should you have gotten with this thing?
Yeah, I didn't leave space in there, so I got it wrong.
You did a what now?
Supposedly I had to put spaces in there, but since I didn't, I got it wrong.
Oh, okay. Yeah, it might be a formatting issue because I may not have accounted for something that someone might have put in there. You have to put it in all different sorts of alternatives. Put brackets instead of braces. So yeah, you definitely want to make sure you're using your braces. So the first thing I think someone said was 16, right? And then the next thing is what?
25,
25.
And then the next thing is,
36.
and then the next thing is,
I think that's all. Isn't it?
yeah, that's it. I was trying to make sure. Okay, yeah, that's it. There's just them 3. I think we're going to what, 40? It was like 10 to 40 or something, I think is what the numbers were. Something like that. So these are the 3 perfect squares between 10 and 40. You put some set braces, Space after the comma usually. So yeah, I mean, with this program, it's probably like really, really strict on how you're writing these things, right? It's a computer, it's going to be. Which I know it's like a point of frustration, but it's also like, it's also a learning opportunity, I feel like. If that's not too cynical. But you know, if you're submitting this written wise, it's not, obviously can't be, I'm not going to be that strict. I wouldn't want to be that strict, you know. So take it for what it is, I guess is what I'm trying to say, right? So Venn diagrams, we want to draw a Venn diagram with 2 circles showing the relationship between the following pairs of sets. Provide an explanation of the diagram you draw. Teachers and women. What do these sets look like? If you're going to draw a Venn diagram, you have a bubble for teachers, you have a bubble for women.
Would it be a subset?
Would it be some SRP from the notes?
Yeah, I was just thinking I was trying to get y'all to give me just like a simpler explanation. So some teachers, was it teachers and women? So if it was a subset, that would imply that either all teachers are women or all women are teachers. So subsets means that like one of those sets would be a smaller set and it would be fully contained within the other one. So subsets, some SRP. So if you say some SRP, what that is indicating is that there is an overlap between these two things. I think that's what you're saying, right?
I think so.
Yeah, somewhat.
So it should be an overlapping set, but it is not a subset. And so what does that look like? I think we've done that. Does this give you, it's just a slide, right? It should look something like this. They should be overlapping. It's not a subset of the other. Does it make sense why it's not a subset?
Yeah.
Okay, because if it's a subset, right, if we could put teachers all the way within women, that would indicate that every teacher that we select is going to be a woman, right? And the thing about that is we need this set right here. If I put an X over here, this would be someone that's a teacher that is not a woman. And since the book is trying to reinforce their gender binaries, this would be a man that is a teacher, right? This would be a woman that's a teacher. This would be a woman that is not a teacher. And out here would be someone that is not a teacher and not a woman. So that would be a man that's not a teacher. So we wouldn't have, what, 4 sets then? We would have like 1, 2, 3 different sets if we had subsets, I think. And we really need those 4 sets. We really need to talk about men who are teachers. And then the other side of it is we also need to be able to talk about women who aren't teachers, right? If you get subsets, you don't get, you lose one of those sets, depending how you draw it. Okay. Teenagers and octogenarians. So how am I going to draw these sets? Octogenarians, I believe, are people in their 80s.
They would be 2 separate circles.
2 separate circles. They are disjoint circles. That is the important thing. I guess the other thing that I didn't talk about too much, but you also probably need to label your sets. This is teenagers. This is octogenarians. Make sure your sets are disjoint. Make sure they are separated for this problem. They're just trying to get you to think about sets here and how those sort of sets relate. Any questions? Okay. So they're just, I think what they're trying to get with these two questions is they're trying to give you sets with something in common. They're trying to give you sets with nothing in common, trying to know whether you can draw overlapping sets or disjoint sets, right? Oh, really? What happened to my questions on this one? They disappear? Or do I have to click? Do they come up on the phone? That is so weird.
No, it doesn't show up.
Oh, I gotta click it. It's got bullet points, apparently. That's what they mean by the bullet points. Got it. So there are a few different questions. I put them all up here. So the first thing we want to be able to answer, and then I think I have these questions separated so we can actually type in an answer. So what I kind of want you to do on this screen is like look at it and figure it out on this screen. And then when we get to the next screens, hopefully you already have the number in mind. So how many people at the party are under 30? And then the next one is how many women at the party are not under 30? The next one is how many men are at the party? And the last one is how many people are at the party? Yeah, the people are under 30. So this is where we're gonna get some practice reading some Venn diagrams and reading some with some numbers in there. So how many numbers are you looking at for part A?
Wouldn't it be looking at 15 and 16?
Yeah, okay. That's exactly what you want to do. Everything in that circle means people under 30. So you have to add some things together for some of these. For most of them, I think you're adding something together. How many women are not under 30? That one you might be able to just pick out, I think, maybe. Alrighty. Okay, I think we're ready to go on. If not, you'll have like a second longer. Use the Venn diagram to answer the following questions. I guess I put these in the bullet ones. Woo! Went through that too quick. Let's do it bullet by bullet. How many people at the party are under 30? We said this one already, right? 15 and 16. So we're looking in this bubble for the under 30. That's giving us the 15 and 16. Part B says how many women at the party are not under 30? What'd y'all get?
Would it be 22?
Okay, so this says how many women? So where are you looking to get the 22? Someone said something else. What are you saying in the chat?
Wouldn't it be 15?
All right, so this is still going to be men. If we look at this 15, this 22 is going to be men. So we want women. So if they say women, hopefully right away you're knowing it down to these two numbers. So if we want women, it's between 16 and 28, and they say they are not under 30. So which one is that?
28.
It's the 28. Yeah, someone said it in the chat earlier, but they said another number with it, I think. I'm not typing stuff in the chat that shouldn't go there. Should be the 28. Come on. What we doing next? There we go. It's this 28 right here. So it might be really weird because they're saying go out of the circle, and this is also saying go outside of the circle. So they're giving you it with like the sort of negation of this thing, right? So they say women, when we see women, we want to look outside the circle of men. When we say not under 30, we want to look outside the circle that is under 30. So that's where we're getting this 28 from. And okay, this is people at a party. So I want to go through like number by number and talk about like what each of these sets is right quick. Because that's really what you should be able to sort of do, right? So this would be men that are what? Not under age 30. So this would be like men over the age of 30. This would be men who are under the age of 30 is right here, this 15. The 16 would be what? Women that are under the age of 30. And this would be women who are over the age of 30, which is the one we just figured out. So if I give you a single spot in here, you should be able to tell me sort of like what set it belongs to. And there's two properties, there's two sets we're looking at. Okay, and then part C says, how many men are at the party? So what'd y'all get for this? Someone's been in my chat. What are y'all saying? 37. And that 37 is coming from, hopefully, let's see, that 22 and that 15. Everything that is in the circle that says men right there. All right, and then the last one, part D. How many people are at the party?
$81.
How many? 81 or 31? What did you say?
81.
81. Okay, yeah. We got to add all the numbers together. Any questions about this Venn diagram? All right, so I'm hoping y'all can pick out sets from a Venn diagram. All right, so the next one we're going to use, now we're doing a Venn diagram with 3 sets. To be honest, we're probably not going to get much larger than 3 sets because as you can see already, like 3 sets, 3, 6, what is that? 7 different little sections in there, something like that, right? 4 sets, it just gets more and more complicated, right? So now we want to know how many people at the conference are employed men with a college degree. So this is, now we're looking at people at a conference. We have 3 different sets. One of them represents women, one of them represents college degrees, and one represents currently employed. So if we look at this 3, this would be what? Men who are not employed and do not have a college degree. So those are guys that are not getting dates tonight, probably. So the first thing is how many people at a conference are employed men with a college degree. The next one we want to look at is, where's that? There we go. How many people at the conference are in unemployed women? How many people at the conference are employed women without a college degree? And then the last one, oh, I can't even read on here. How many women are at the conference? Okay, let's go. I think I got them going one by one now. How many people at the conference are employed men with a college degree? So where are we looking at? So I think where we want to look at. What are y'all saying? Someone say it already? 16. I don't know. I have to look. It is not in the women's circle. They are employed, so it should be in this white circle, not in this one. Is it in the college degree? And they have a college degree. So I think someone said this 16. I think you're right. I think it should be that 16. So the first thing, it says it's employed, so it should be in the white circle. It's not in the blue circle, but it is in the red or pink circle. That's based on the language that they're doing there. So that should be that 16. Let's say that's right. How many people at the conference are unemployed women? So it looks like we're looking at employed, and it looks like we're looking at women. What are y'all saying? 20. 20 is close. And 4. So 20 and 4 makes how many again? Sorry. That'd be 20 and 4 makes 24, right? I think that's what it should be, right? Do we see that? How many people at the conference are unemployed women? So it should be in the blue circle, but not in the white circle. So everything in this blue circle that's not in this white circle is the 4 and the 20. If we put the 4 and the 20 together,
Would it also be the 9 with the college degree? Wait, no, never mind. No.
that wouldn't go in there, and that's a good question. Why does it not go in there? Because it's not a
That's not a
woman.
one.
It's got to be a woman. Only a woman. 4 and 20. Give me 24. And the next one says, how many people at the conference are employed women without a college degree? Four, 8. Let's say employed. It's got to be employed. It's got to be women. But they cannot have a college degree. Oh, never mind. I think I read it. I think someone said it in the chat. What is everyone else getting? Anybody else?
Would it be 12 because you're adding 4 and 8?
So the 8 definitely goes in there. What about this 4? So this 4, I think they have to be employed, right? So are these 4 employed right here?
Okay, I get it now.
Yeah. So it should be what?
8.
It should just be the 8. Why is it like, ooh, come on, refresh quizzes. I don't know why you're doing this. But yeah, it should just be the 8. Yep. And yeah, I don't I'm trying to think of how to say this without sounding like too much like a jerk. But like math is gonna like require you to do some practice. And with these, it's gonna take some practice, right? Like, but basically what you're either saying it's inside the circle or it's outside the circle. And I've taught this class a few times. I've looked at the question a few times by now, so. I imagine I have a slight advantage to knowing how to do these Venn diagrams by now. So how many women are at the conference? And so what is this telling me? This is telling me look inside where?
To look in the women's circle.
Yeah, look in this women's circle. And how many numbers am I going to add together then?
All of them.
How many are there? Like how many of these numbers?
Four.
There's 4 of them, right? Okay. I was just making sure we're all seeing the same numbers there. I'm adding those 4 numbers together. I should be getting 43. I think someone already said that in the chat. Questions about these? I can't see y'all's feedback on these numbers. So like, whoo, I'm kind of assuming y'all are working along. Don't let me down. Don't let yourself down mainly, right? It's like you're taking and paying for this class. All right, 65. I believe this is the last one. So we want to construct a Venn diagram for this thing. So you should have 3 circles. One of them should be labeled A, one of them should be labeled BP, and one of them should be labeled P. Can I do this at the same time? Let's see. I think we're gonna do this. I got enough time to break this down, I think. Okay. Let's see, can y'all see this? There we go. So it says A only is 12. So if I'm looking at this, I got my A, I got my BP, I got my P. If I want A only, means I'm putting it in the A circle and no other circle. So outside here, I believe is. So if I give you a Venn diagram, I should be able to point to like any sort of spot in any one of these circles or any one of the multiple circles, right? And you should be able to tell me like what that little section in there means. The other way is the way that we're doing now. If I give you numbers and I tell you what the section means, you should be able to construct a Venn diagram from it. So A only is 12. The next thing that they tell us up on here is that A and BP only are 15. So we want it in A, we want it in BP. So that's this area right here. If I put it in here, it's going to be all 3 of them. So I really want to put it right in this overlap. It looks like my 15 is going to go up in here. Are there questions about this? Do you think you could fill something like this out is what I'm asking you? based on that table that they're giving you. All right, so what's growing? What number am I putting out over here?
Eight.
All right, so here we go. 8 goes right out there. That's the BP only. What am I doing? Here would be what? A and P, what am I getting there?
24.
24 should be the number that I'm putting there. P only is 22. That's the thing. BP and P. 16 right here. None of them. Where am I putting that at?
Outside of the,
Outside, but still in the box. There are 2 of them. Ooh, excuse me. And then taking all 3 medicines. I got a 20 in there. Are there any questions about this thing, about how to do a Venn diagram? Draw your circles. Don't forget your box. Always don't forget about the universe. Whew. And usually if you're doing a proper like Venn diagram, you might want to say what, medication or something here. Or title. Maybe I'm being a little bit lazy. But if I was displaying this for someone and wanted to make it pretty. All right, so let's go back. We got our Venn diagram. That is part A. Part B is we're going to go look at that Venn diagram and we're going to pull out numbers from there for B to F, basically, right? I think it's easier to look at the Venn diagram first, though. So let's go to the next thing. I think it's got the Venn diagram on there. That should be what I drew. Hopefully all those numbers seem like they're matching up. So now we want to answer these. How many patients took pain medication or blood pressure medication?
Is it 22 and 8?
22 or 8. So this would be in there because they took pain medicine. This would be in there because they took blood pressure. What about the 16?
would it be 59?
Where are we getting 59 from?
I think it may be a little bit confusing because you put or instead of and.
Was it supposed to be and?
I'm not sure. Because would it be
No, it's or.
then would it be 16?
I misread the question. That's my fault.
It would be this 8. It would be this 22. It would be this 16. What about these people? Did these people take pain medicine or blood pressure medicine? These 20?
Yes.
Yeah, them too. What about these people? Did they take either blood pressure or pain medicine?
Yes. I just forgot to add the people for the pain medication.
If I wanted everyone that took pain medicine, I would add up, what, these 4 numbers? So what I want is everyone that's either in pain or in blood pressure. So or really kind of acts as a addition sort of thing, if I'm being honest. We're kind of adding sets together. If you added this together and you added everything in this together, there would be some overlap. So there's an issue with adding the overlap twice that sometimes people might accidentally do. Don't do that. But there's a potential that there's some overlap, right? But how many numbers do we have to add together? Are y'all seeing it?
Would there be 5 numbers to add?
I think there's 6 numbers, right? There's these 4 and then these 2. Everything but the 12 and the 2, basically. Should be, this is everything in pain, this is everything in blood pressure. Do y'all see that? Do I need to explain it more? How does it look? Is that it? 3, 6. Yeah, it's 6. Ow. Is that making sense, hopefully? This is everything within the P circle. This is everything within the BP circle. All right, so how many patients took blood pressure medicine, but not antibiotics? So what numbers am I looking at? So I'm not even expecting y'all to add these together. Like, I'll add them together for you if you want. I want you to be able to see the sets. I know I hope you know how to add by the time you get to this class. That's not what I'm trying to test you on, right? I want you to be able to pick the numbers off of this thing.
Would it be 8 and 16?
Okay, so yes. So we want blood pressure medicine. So right away, I know I'm looking at like these 4 numbers over in here. We want blood pressure medicine, but not antibiotics. So I have to keep it out of this circle, out of the A circle, but within the BP. Looks like this 8 and 16, and we add those together, that should give you 24. Okay. Part D says, how many patients took at least blood pressure medication? So they could have took more, but they took at least blood pressure medicine.
8.
Okay. That would be only blood pressure medicine. So
Would it be 15, 20, 16, and 8?
yeah, everything that at least has blood pressure medicine would be everything within the blood pressure medicine circle. So that'd be the 15, the 20, the 16, and the 8, everything within here. So these people took more, right? These people in these overlaps, they took more medicines, but they also took blood pressure medicine. So they took at least blood pressure medicine. $15, $8, $20, and $16 gives me what, $59? How many patients took only pain medication? Oh man, you could have got this one straight from the table even, I think.
22.
22 right there. How many patients took exactly 2 medications? No more, no less. This is a weird question to ask, but it's there. I guess it's a valid thing to ask. What numbers am I adding together?
24, 15, and 16.
Yeah. So these intersect exactly 2 circles, which means they take exactly 2. Why wouldn't you include the 20? Because they're taking 3 medicines. You don't include these because they're taking 1 medicine. You don't include this because they're taking no medicine. So the ones that are taking 2 medicines are the ones that are in the overlap here of just the 2 circles, but not the 3. So 24, 15, 16, we add those together, should give you 55. All right, I think that's the end of the lesson. Oh boy, let's see. Where am I at? I'll ignore that person. They're not important. They don't even have a name. Look at that. Student 1. No. All right, so this is a real placement. Scroll through it real quick. Natalia came in and dropped out. So one of hers is way up there and one of hers is way down there. Okay. And I'm going to stop sharing. And if you have any questions, let me flip my camera back around so I'm a little more approachable maybe. Ooh. Okay, so if you have any more questions, I will be around. We're right at the end of the class, so that is about it.